Engineer Vidya and Engineer Bhaskar from PWD on a stage to give the presentation on economy and social outreach by rainwater harvesting system.
Vanakkam. Mom, good afternoon to all of you. I am Vidya, Assistant Executive Engineer, and he is Bhaskar, Assistant Engineer. We both were working closely with the JICA team for the past 6 months or so. So I take this opportunity to present some cost aspects as well as the societal impact of this UN tank. And initially, Bhaskar will present on the cost aspects. Later, I will take over for the social aspects.
Good afternoon to everyone, and my greetings and warm welcome to you all for the technical workshop of the rainwater harvesting underground storage systems sponsored by JICA teams. And broad and overview of the existing conventional system of rainwater harvesting systems and compared with the JICA systems. First of all, it contains an economy view and as well as a social outreach. And as well as our observations of these projects is composed structures. Basically, it contains of plastic as well as concrete. But our conventional concrete contains only steel as well as concrete. Then conclusions. Basically, in engineering underground storage tanks, if the width of the tank is 3 to 4 meters, there is no need any beams. The slab can take everything. If the span width of the tank is more than 4 to 7 meters, then the beam will necessary to take slab loads as well as everything. If the span meters, even only at the 4 to 7 meters, we can provide at the end of columns. No need any intermediate columns. If the span meters more than 7 meters, span of the tank, if the span of, here we have 12 meters, there is no any intermediate supports. Only we have at every 67 centimeters intermediate support only. That is uniformly supported like a mesh, like how to say, the finite element methods. The concept is like this. There is no any support at all. No beams and no columns. So if it is more than 7 meters, we need to provide beam and slab as well as column. To take care more loads, we need to provide the raft. Raft almost minimum it comes around 50 to 60 centimeters. If you provide 50 to 60 centimeters, automatically the cost will more. So we cannot use for the large scale volume of storage capacity. So it is better for this JICA system is more and more suitable for this large scale storage capacity. Then economy. Normally, a rainwater harvesting systems by underground storage tanks about rupees 12 per liters. For a domestic purpose, everyone can design rupees 12 rupees per liter. Based on the 12 rupees per liters, if you are purchasing through Metro Water or any private lorries, they contain almost quantity of 12,000 liters, or it may be available 24,000 liters. For individual domestic houses, they can having only small sums. It contains one truckload. If you are buying one vehicle lorry water, they will buy and unload it into sums. It contains around 12,000 liters only. So for that, we need to spend rupees 1.4 lakhs approximately, because it is already worked for rupees 12 per liters. It depends on quantities. And again, economy views. For an individual residential houses, our conventional RCC storage tank is always economical. Whereas for community basis, like storage tanks like offices and multiplex complexes and apartments, medium and small scale industries and other theaters like in public events, like government hospitals, whoever needs more water and more requirements, that type of large scale storage capacity that uneconomical for our conventional existing concrete methods. Economy for the project cost, whereas it contains composite such as like composite method and conventional methods. First, civil works. In composite methods, from the earthwork excavations, sand filling, plain cement concrete, brickwork, raft concrete, wall concrete, plastering and everything comes on civil works. It comes around 34 lakhs in JICA methods. In the plastic parts is available, only pinch pipes is made, these pipes for customized. Actually, this pipe is not available regular shape, regular size in market. Usually 150 mm, 6 inches pipe only is available in the market. But it is a partition plate, like the shoe. bottom black color plate is customized in Japan in 164 So we cannot use 160 So the pipe is conventionally customized by, especially for these projects. The vertical pipes, all the pipes prints made by is around comes 13.85 lakhs. The cost of shoe, the cost of partition plate, shoe as well as cap, like it's called a partition plate, that cone shape is the spacer. To attach the spacer as well as partition plate, we need to attach the attachment plate. So it comes around 55 lakhs. Then custom duty for especially in government projects, if you are purchasing through private sectors, we need to pay 30% custom duty. For the research project, we are paying only 5% of the custom duties. Whereas it comes around, the total cost is become around 106 lakhs, 106 lakhs. Whereas in conventional method, it comes only 83 lakhs. How to break even the economy? Everybody thinking now it is our conventional method is best than the JICA method. How to JICA method is most suitable than our conventional methods. If you are thinking that the large quantity of volume of water is demand. The same case, the civil work will be the same. Wherever goes earthwork, civil, sand filling, brickwork, and everything is common. So the first cost of will never change. The vertical pipes also never change because already the vertical pipes is manufactured in India. Whereas the cap or shoe, that is a partition plate and spacer and attachment plates, how it comes 35 lakhs. If it is manufacturing in previous slides, it is manufacturing in Japan, it shows 55 lakhs. Suppose the same partition plate and attachment plate is manufactured in India, it is cost, no need to pay any custom duty. Moreover, in Japan, the cost will be very, very expensive. So if the same product, it is manufactured in India by locally, we no need to pay any custom duty, and moreover, the cost of the product will also very less. So once after manufacturing in India, it comes around 35 lakhs. So automatically it comes very equivalent to both customized method as well as the conventional methods. How to economy in the local manufacturing of the plastic parts. Civil works the same cost. Vertical is also same cost. How it comes 13.83, strike out the 30.503 lakhs. Because usually the PVC pipes sold by the, what are the materials using for the PVC pipes? And the bottom partition plate and attachment plates are using for the polypropylenes. That is a grey color pipe is a polyvinyl chloride. That is PVC. The standing pipe is a PVC. That plate is polypropylene. Everything depends on the raw materials we are using. It's almost the bottom plates coming around 8 kg. 8 kg. If you take the weight, it's coming around 8 kg. So similarly, if you're manufacturing locally, the cost also comes equivalent to vertical pipes cost. So after by calculating that in outgoings around this comes 62 lakhs, whereas in our existing methods comes around 83 lakhs. If it is cost comparison with probable savings will come 21 lakhs lesser than our conventional methods. It's quite saving for us. And moreover, if you are going beyond the, how to say, if this is a very medium size, it's not a big size actually. If you are going very big size, we will get more and more savings of the prices. And the JICA will break even if the cap and the shoe, that means partition plate and the spacer and the components are manufactured locally, then it will go very, very economical sections. Messrs. Totostove Manufacturing Co. Limited is working with manufacturing locally with a joint ventures. They are looking also in India. Then this technology will very much cost effective than the conventional concrete methods for the larger size. For example, if you are using, this is around only 6 lakhs. If you are going at 25 lakhs, 30 lakhs, surely this method will be very, very economical than our conventional methods. Now about the social outreach, my colleague Ms. Vidya will explain the presence.
I am here to speak about the social outreach of the rainwater harvesting system. As a government employee practicing for more than 18 years, I firmly believe that each one of us have some kind of social responsibility towards, contributing towards the better water resources management. When I went to my daughter's school, as part of the mentoring program, So even when I was speaking about some water aspects to lower primary school children, one smart boy smartly asked me, Auntie, you are working for 20 years in this department. What are you doing about the water? So we as part of water resources department, we should set a role model to our peers and other neighboring public also to conserve and save and water in the most efficient way. In that aspect, I'll speak a little on this. The social outreach of the rainwater harvesting system, we were speaking a lot on the managers of the waters, from people from water resources, field people, the TWAD people, the metro water people, all people were visiting. So we were setting a role model kind of thing that, we inside the water resources department as groundwater people, we are doing a pilot, we are taking up a new innovative project. And setting an example and trying to check if this is cost effective or proving to be economical in the longer run. So we took the first step. I thank the JICA team on the groundwater, on behalf of the groundwater department, to have given us the opportunity to implement this project. The staff of Tamil Nadu PWD are sensitized. Not only Tamil Nadu PWD, the whole water managers, all the stakeholders have been sensitized on the feasibility and benefits of rainwater harvesting. Till now, we were just doing the local, household rainwater harvesting and the conventional methods of, check dams or percolation ponds and all. This is a new thing. So we were sensitized, the staff has been sensitized on the new technology. The poor in the neighborhood will be provided purified rainwater at rupees 1 per liter and rupees 5 per 20 liters. Actually, all of you who are coming to our campus for the first time would have noticed a water ATM installed at the gate on the right side of the gate. This is Chennai is a very water scarce city. We have seen on the harsh summer months we have seen people fighting, old women, children, and all fighting for water. So our campus is sitting amidst the slums and low income group. We should be contributing some towards them. So as part of this project, we not only we are providing the drinking water for all the buildings inside the campus, and also we are providing an ATM to provide for the basic drinking necessities of the low income people around our campus. The next one is neighboring infotech parks are our future clients. We are amidst the big Ascendas IT park. There are 3 annexes and we are in the main OMR IT hub. All of these IT companies have been buying lorry water only. They don't know about water resources and management and all. So it's our duty to let them understand that we can save and conserve rainwater like this, and we can easily do away with the lorry water. Social outreach by the rainwater harvesting system, I'm continuing. We apprise the business visitors who visit to our office about the rainwater harvesting through UN tank. Throughout the 6 months construction period, there have been almost 2 to 3 visitors on a weekly basis. Me and Bhaskar and Anbar sir had been constantly briefing on the new technology on all the visitors, people coming from factories, industries and other NGOs and other private players. All of them were, briefed about how to construct this. Some of them have shown interest in trying the UN tank as the solution for their water demands. Mainly this Mothers and Automatics Chennai and SSS College for Women. Just now, while speaking to my IIT professor, Mrs. Indumati ma'am, she also was mentioning that, we should also try this in an IIT. Because IIT being a very, very big campus, they have plenty of space. She also was coming forward. We appreciate a lot for your suggestions, ma'am. Other government agencies like TWAD, Metro Water visited during construction. All people were encouraging. Many engineers visited. Our own Swarma people, IWS people, all engineers were visiting and giving a lot of encouragement to us. Students in academia like IIT Madras, I am a research scholar in IIT, so many of my research scholars were also visiting and they were also greatly interested in such a new kind of project. Our observation as part of the JICA team, the UN tank team, is the underground storage tank by the Japanese technology is economical when the tank size is of the order of 40 lakh liters. Actually, now we are constructing only 6 lakh liters. Actually, that's mainly because, we wanted to supply, first, as a pilot project, we want to take the first test small. So in between these two buildings, whatever the space could accommodate, we accommodated 6 lakh liters, and we have only 250 people, staff in our campus. So more than that, we did not attempt now. But our observation is that if it is around 10 lakh liters or more than in 20 lakh liters, where you have some 15,000 employees to cater for, such tank is proving to be greatly economical. The imported plastic components are manufactured locally. This is another learning curve for us. While we were doing about the customs clearance procedures and all, we realized that JICA was not exempted from the customs duty, whereas the World Bank, other many of the Asian Development Bank were. I don't know why. It's my humble request to the JICA team to consider that. Go please fight with the customs people to give you the same regard as the World Bank. Why JICA is also giving the same kind of work. So why JICA is not given that much exemption? Because of the customs duty, we are not proving to be cost effective. Because we could just bring down the custom duty from 30% to a little. We could just do away with the whole custom duty in the next project if you try. Next one is, we are reaching out, as I told you earlier, we are reaching out to the weaker section through water vending ATM. Actually, this is a very great boon for our, women around our campus. They are all, I have seen many, when I was standing and cleaning up the sewer lines during the floods, I have seen many poor ladies, struggling to get even one kodam வாடுறதுக்கு அவ்வளோ கஷ்டப்படுவாங்க. அதுக்கெல்லாம் சேர்த்து நம்ம it's for a little money, 1 rupee or 5 rupees, we are providing them with some water. We reach out to the corporate sector through sales at a competitive price. This is a policy decision to be made later. Actually, if we think that, in a good monsoon year, our tank gets filled and, it's more than our requirement, we could very well, with the approval of the authorized people, we can sell the water and get some revenue also. This is pending policy decisions. Beyond monetary value, a great awareness raising on the concept of rainwater harvesting is achieved. Because we are constructing such an innovative structure inside our campus itself, it's a kind of awareness, and whoever people who are visiting for data, our office is State Water Resource Data Center. So hundreds of people visit our campus on a daily basis for getting all kinds of rainfall data, climate data, and groundwater level data. We can show all of them and raise the awareness they have on rainwater harvesting structures. So my conclusion, JICA-sponsored Messrs. Tosetsu Manufacturing Company Limited Technology has immense potential in large-scale rainwater harvesting in India. And I again reiterate, it has immense potential in large-scale rainwater harvesting in India. Like for, say, example, in general hospitals or underneath the big stadiums, we can propose such technology, and which can be proved cost-effective, and the land use can be continued the same. So the stadium can be used as a stadium, hospital will continue to use as a hospital. And I thank this, all the higher officers to give me opportunity to present this. I thank the JICA team, all my co-workers, especially Hisanaka-san, who worked with me and Bhaskar on a daily basis. I was actually greatly appreciate his work. He comes at 8 o'clock in the morning and leaves by 8 o'clock in the evening, which even I and Bhaskar could not do because of the harsh things. So I greatly appreciate, thank one and all. Thank you.
Good afternoon, ladies and gentlemen. I am the last presenter. Unfortunately, I am the last presenter. I guess that you're getting very tired and getting very hungry, so I must finish as soon as possible. Please be patient hearing my last presentation. My presentation related to the Japanese policy nowadays related to the sound water cycle. Next, please. But I got some trouble. So next, please. This is the contents of my presentation. Firstly, I explain about information from the headquarters for water cycle policy, the cabinet of Secretariat in Japan. Next, sound water cycle in urban areas and third one is a country-specific approach for sound water cycle in the world. And then comprehensive flood control in the Japanese policy, and then rainwater utilization facilities in Japan, and the future direction on the promotion of rainwater storage and infiltration facilities. Because my association name is Rainwater Storage and Infiltration Technology. It's very easy to understand. We are already thinking how to promote this kind of facilities for the sound water cycle, especially in the urban areas. Next, please. This is the information from the headquarters for the water cycle policy. Left-hand side on the top, this is the definition of the water cycle. You can see the figure regarding the form of the sound water cycle. Of course, you can easily understand that the water cycle is the precipitation, storage, infiltration, runoff to river, water use, water treatment, and then go back to the evaporation to the sky. So this is a cycle. This is a natural cycle, but due to the urbanization, this is natural cycle. It's deteriorated, especially in urban area. So we have to again some measures to make it the deteriorated cycle to be as natural as possible. Next, please. So although the issues surrounding the water cycle have been improved to some extent, but some issues still remain. There are concerns that new issues will be arise due to factors such as depopulation and climate change. So we have many kinds of issues related to the natural water cycle. For instance, we have to reduce the infiltration of the rainwater. It's reduced due to the urbanization. And we have a flood damage due to urbanization. Also, we have water pollution of the public water areas. Well, we need a sustainable effectiveness of water source recharge function of the forest. Or reduction of, we are facing the reduction of the recharge function due to the increase of the hollow fields, or decline in the groundwater level, or land substance due to excessive pumping, or degradation of the stability supply capacity of the water supply facility due to the depopulation. So, in Japan, in year 2014, about 4 years ago, we set up the basic law on water cycle. Then the headquarters for water cycle policy in the cabinet secretariat were established. And then they clarified the basic philosophy when implemented water cycle measures, or clarify the responsibility of the people involved in the water circulation, such as the national government or local government or business operators and students. And the establish of the basic plan on the water cycle and clarify the basic measure to promote water circulation measures. This photo shows that Prime Minister Abe is head of the headquarters for water cycle policy. Next, please. Next one. So this is the contents to be written in basic plan on water cycle. It is announced by the government, national government, under the basic law on water cycle. There are many titles to be written in the basic plan. Only the national government specify the contents of the planning, but actual planning should be done by the local governments. So this is very easy. They just put the title, it's all. But it's very difficult to make actual plan in any places by local governments. The point is that the fundamental policy for measures, we say that comprehensive and unified measurement for river basin. I think in Japan, since that we are a small island, so the catchment area of the river basin is very small, so very compact. So in Japan, usually we say that we should make a plan, sound water cycle plan should be made in the size of the river basin. It's a characteristic of Japan. And second, they say the part two, they say that promotion of the basin-wide cooperative cooperation, framework of the comprehensive and unified management for river basin. This is also same. We should get together in the size of the river basin to make a sound water cycle plan, cooperate with the citizens, government, and many relevant people. And then the second one is preservation and improvement of the storage and groundwater recharge. This is quite related to my association. They say that forest, river, and agriculture land, especially urban area, is very important to have the rainwater storage and infiltration facilities. Should be distributed in urban area. And also, the next one is a promotion where appropriate and effective water utilization. The water utilization is also, they say that is very important. Next, please. Then, the national government compiled for the first time the plans for the regions which has been working on the maintaining or restoring their sound water cycle, and on January 16, year 2017, announced officially 70 plans as the first step of the basin-wide water cycle plan. So government announced that they selected 17 plans, firstly, and secondly, on April 13, year 2017, 10 plans were added. So totally 27 plans are going on in the very local areas. You can see the Japanese map there. It is written in the Japanese, but you can say that there are many places distributed by the project plan going on, supported by the government. Next, please. So there is some detail for the 27 projects related to the sound water cycle. Maybe I don't have the time, so I just quit this slide. Next, please. So next one is what is the sound water cycle in the urban areas? This is left-hand side is a natural area, right-hand side is an urban area. What is the difference? Maybe in the urban area we have a pavement and many buildings, so the infiltration becomes very small, and instead of that, the runoff on the surface is greater and greater. So we need the river to be enlarged and excavated and then concrete lining. It's not a natural river anymore. And also the groundwater level is getting down. So this is the problem in the urban area. The next, please. So this is the viewpoint of well-balanced hydrological system. In Japan, our group insists that which is necessary that water cycle should be well-balanced in the stormwater control and effective water utilization and aqua environment improvement. So we should think of the balance of these three items. Next, please. So this is a figure referenced by the Australian group. What they say is that the urban water management transition framework. In the left-hand side, previously we concentrated on the water supply. Next one is the sewer system, and drain system, then waterway system, and water cycle system. Now the Australian people, they say that the water sensitive city. It's very difficult to understand, but they say water sensitive city. So now it's a target to be to make a water sensitive city any places in urban area. Next, please. This list shows that country-specific approach for sound water cycle. Nowadays, in whole in the world, they are going in the same direction related to the sound water cycle in the urban area. In the USA, they say that low-impact developments. And UK says that a sustainable urban drainage system. Germany also sustainable urban drainage system. Australia, I already said that the water-sensitive urban design. And China say that sponge city. Sponge city is very understandable. And Japan, we don't have very good English, but just say well-balanced hydrological system. And next, please. And Singapore, they say that ABC, active, beautiful, clean. And Korea say that smart water city. And Netherlands, they have a water square. Next, please. Now, this figure shows that in Japanese policy, especially in the flood control, we say that comprehensive flood control from the River Bureau in the national government. Because in the previously, the River Bureau concentrate river itself, only river itself. They improve the river channel. They never touch to the area, basin area, because in the river law says that they have to get out of the river line. They cannot touch to the fields. But they say that in the urban area, it is necessary to have measures distributed in the basin area. Then you can see that this figure in the yellow hatch, basin-wide allotment. It's related to my association. We distribute many small facilities, say storage and infiltration facility. Even that the facility is very small, but it is distributed in the basin-wide, it becomes very effective. And also, sewerage division has measures in the comprehensive flood control. Or the riverside also, they have a regulation pond. And also, the conservation of the natural land is also very important. Next, please. This figure shows that in Japan we have many kind of the storage facilities in the urban area, but this is our association dealing with that. Nowadays there are many alternatives to set up the facilities. So many places, there is if we have a space, we can think of how to store the rainwater. The next one, please. I don't know, as for the infiltration, I don't know is there any good place in India, but in Japan, especially in the Tokyo area, we have a very good soil condition, which is made of the volcano ash from Mount Fuji. The infiltration capacity is very high. So there are so many infiltration facilities distributed in this area. And this is also very effective and in the flood control, not only flood control, but also this is a function to recharge the rainwater to the ground. It is very important. Next, please. Also, regarding the rainwater utilization facilities, I think that condition is quite different from the India, especially South India. You are facing the shortage of the rainwater, not the shortage of the water, but in Japan, especially in the urban area, we have enough water supply. So it is very difficult to promote rainwater utilization facilities, not like here. But this is the graph is expressing the secular change in the installation of number of the rainwater utilization facilities. You can see that somewhat improving the number of the facilities. The lower one is total volume of the rainwater utilization, also getting bigger and bigger gradually since more than 40 years ago. Next, please. This is rainwater utilization facilities, especially in the large-scale rainwater harvesting. Especially in Japan, this kind of large-scale facility is installed in the dome, which is a soccer stadium or a baseball stadium, something like that. We have listed in here the storage capacity is more than 1,000 or 3,000 or 4,000 cubic meter. Next, please. So I finalize my recommendation that in Japan, the left-hand side is a flow in the comprehensive flood control, because we started with a comprehensive flood control in this topic, but since we have a necessity of the sound water cycle in 1996 already, and our rainwater storage and infiltration facility is related to the both. But since we have a basic law on water cycle in year 2014, so maybe in the future, our association will take this direction based on the sound water cycle. We would like to promote my facilities in the future. Thank you for your attention.
Ladies and gentlemen, now please welcome our Japan team on the stage for the appreciation and honor for those who involved in the project for their sincere efforts and cooperation in construction of rainwater storage system at PWD. We now call upon on stage Engineer C.T. Sankar. Engineer L. Chitambram. Now we call upon the stage Engineer S. Bimla. Now we call upon the stage Engineer S. Anthony Ambrasu. Now we call upon on a stage Engineer Mr. Raja. Now we call on a stage Engineer Vidya. Now we call on stage Engineer Bhaskar. Now we call on stage Mr. Madhuvan from Prince Pipe and Fittings Limited. We now call upon a stage Mr. Hari from Akroma Water Treatment System. We now call upon a stage Mr. A. Gerald. We now call upon a stage Mr. Robinson from Roach Constructions. Now Mr. Imbe would like to explain about the souvenir he gifted to you.
That one is a very small one. But usually if you open it, it's one set of the sweets, very small sweets. And the color is red and white. Red and white means that celebration in Japanese. So since it is very small, but please take it to celebrate our achievements. And please take it by this month. Okay, thank you very much.
Let us welcome Engineer L. Chitambram, Chief Engineer Director, Institute for Water Studies, Water Resources Department, for the vote of thanks.
Good morning, ladies and gentlemen. First and foremost, thanks to Japan International Cooperation Agency, JICA, and Toyotsu Manufacturing Company of Japan for their generosity to implement this rainwater harvesting underground storage system in this campus at free of cost. As we know, the cost of the project is around 106 lakhs, but they have given us at free of cost. My hearty thanks to Mr. Okeyu, Mr. Imbe of Japan Rainwater Harvesting Society for the technical cooperation since inception to till completion of this project. I extend my kind thanks to Engineer Batmanaban, Special Secretary to Government, Public Works Department, Government of Tamil Nadu, Chennai, Engineer M. Bhaktavachalam, Engineer in Chief, Water Resources Department, Government of Tamil Nadu, Chennai, Engineer S. Vimala Madam, Chief Engineer Director, Swarma, Engineer Thiru C. Paul Prabhakar, the Regional Director, Central Groundwater Board, Engineer Satyamurthy, CE, O&M2, Metro Water, for their participation in the function and their special address. My special thanks to Engineer C.T. Sankar, Chief Engineer, State Ground and Surface Water Resource Data Center, Water Resource Department, Government of Tamil Nadu, for his advice and cooperation extended during the project and make it a successful project. My immense thanks to Engineer Anthony Anparasu, JCE, State Ground and Surface Water Resource Data Center, Water Resource Department, who have successfully completed this innovative rainwater harvesting project with the assistance of Engineer Vidya, Engineer Shekhar, and his team. I thank all his team. I thank all the engineers, the rank of executive engineers, assistant executive engineers, assistant engineers, and administrative staff from State Groundwater, Institute for Water Studies, and from Sorma for having facilitated this function. I also thank the workers who are actually involved in construction of this project. I once again thank the team who has arranged this function. Thank you.
Well, I believe that's about everything, ladies and gentlemen. We have finally come to the end of our workshop. It has been a great day and a wonderful day with all of you. Again, thank you for all your presence. God bless and good day to each of every one of you. Thank you. Ladies and gentlemen, would you please be standing for the national anthem?